In this video, we will learn about the remainder theorem. If we divide the polynomial function p of x equals x cubed minus 2 times x squared plus x minus 3 by x minus 2 using synthetic division, we find that the remainder is negative 1. Notice that if we evaluate the function at x equals 2, the result is also negative 1. That is, p of 2 equals negative 1. This leads us to the remainder theorem. The remainder theorem states that if a polynomial p of x is divided by the quantity x minus a, then the remainder is r equals p of a. Recall the division algorithm p of x equals d of x times q of x plus r of x, where p of x is the dividend, d of x is the divisor, q of x is the quotient, and r of x is the remainder. Since we are dividing p of x by the quantity x minus a, let d of x equal x minus a for any real number a. Then, p of x equals the quantity x minus a times q of x plus r of x. The degree of the remainder is always less than the degree of the divisor. Therefore, the remainder must be a constant. Let's call it r so that r of x equals r. Now, we can rewrite the equation as p of x equals the quantity x minus a times q of x plus r. Let x equal a and rewrite the equation as p of a equals the quantity a minus a times q of a plus r. Note that a minus a equals 0. Because 0 times q of a equals 0, we can simplify the equation to p of a equals r. Thus, we have obtained the remainder theorem. The remainder theorem tells us that polynomial division can be used to evaluate a polynomial function at a particular point. Let's look at an example. Let p of x equal 3 times x cubed plus 2 times x squared minus 8 times x plus 2. We will evaluate p of 2 using two methods. In part A, we will evaluate p of 2 directly. In part B, we will evaluate p of 2 using the remainder theorem and synthetic division. To evaluate p of 2 directly, substitute 2 for x and then simplify. So we have p of 2 equals 3 times 2 cubed plus 2 times 2 squared minus 8 times 2 plus 2. Following the order of operations, rewrite the equation as 3 times 8 plus 2 times 4 minus 16 plus 2. Simplify to get 24 plus 8 minus 16 plus 2, which equals 18. Now, let's evaluate p of 2 using the remainder theorem and synthetic division. By the remainder theorem, if a polynomial p of x is divided by x minus a, then the remainder is r equals p of a. So, to evaluate p of 2, divide p of x equals 3 times x cubed plus 2 times x squared minus 8 times x plus 2 by x minus 2. Set up the synthetic division using the test point 2 and the coefficients of the polynomial 3, 2, negative 8, and 2. Carry down the leading coefficient, which in this case is 3, and continue the process of synthetic division. 2 times 3 equals 6. Adding down the column, 2 plus 6 equals 8. 2 times 8 equals 16. Adding down the column, negative 8 plus 16 equals 8. 2 times 8 equals 16. Adding down the column, 2 plus 16 equals 18. Using synthetic division, the remainder is 18. By the remainder theorem, this tells us that p of 2 is equal to 18. As you can see, this is the same value we found in part A by evaluating the polynomial directly.